In this video, we will determine the clamping force by analyzing a square thread power screw. We will simply determine the force by using the following equation. Okay, so let's do this calculation-based FE type question, and we're going to be discussing and solving an FE question for power screws. So we're looking at square thread power screws, and we want to find the force, the clamping force, when we have a torque that's raising this power screw here. So our screw in this figure, for our clamp, is going to be this, as highlighted here, and here we're just giving a better view based on this, what we're seeing, and we have a collar that's rigidly attached at the top, and we have a section cut as well. So we're given a section cut. Picture this being the section cut through the screw here. So this is a section cut for us that's given as well. So we know here we have a single square thread power screw. It's a single square thread is attached to a screw clamp as shown below. As highlighted by the section cut below, the screw has a major diameter of 32 millimeters and a pitch of 4 millimeters with single threads. So that's some information we need. The major diameter here is 32. It's going to be this. And this is not denoted in the figure, but it's going to be capital D. So let's write that as a given. You want to always state the given. And here, capital D, which is the major diameter, it's 32 millimeters. And we're told the pitch is 4 millimeters. So P is 4. And we have single thread. So that's important. Single thread. And the mean collar diameter is 25 millimeters. So this is D sub C. Collar. Mean collar diameter is D sub C. And that's 25 millimeters. And what else are we told? We're told the coefficient of friction for the thread and the coefficient of friction for the collar are the same. So this is for the thread, this is for the collar, and they're both mu for the thread equals mu for the collar is 0.08. They're both 0.08. If the torque of 26 Newton per meter is applied to raise the screw, so here we're raising the screw, so T sub R for raise is 26. And the applied clamping force in kilonewton is most nearly what? So that's the given. What you want to find is the clamping force F, and in units of kilonewtons. That's the final units we need. And I believe we're given the answer choices here. So we're solving for this clamping force. What do we do? So we know we can refer to the handbook. There's a handy equation that's derived for us, and this is also derived usually in your machine design textbooks using the statics principles. So we're not going to derive the equation, we're just going to learn how to use it. So that we know we're using the T sub R, the raising torque, for power screws. Under power screws, we're looking at specifically square thread power screws. The torque required to raise, T sub R, is going to equal the force times D sub M divided by 2 times, we have the L, it's the lead, L is the lead, plus pi times mu times D sub M divided by pi, we have D sub M minus mu times L. Then we have that essentially this portion of the equation is for the thread. So now we're going to consider the resistance for the collar. So we have the force, then we have mu for the collar, diameter for the collar, the mean diameter, which is given, divided by 2. So as you noted, this side is for the thread, then we add the additional resistance for the collar. So here we know we need D sub M. We do not have L, but we can essentially find that. And we need this D sub M. D sub M, if we go to our figure, it's just going to be arrived at by taking D and subtracting P over 2. The pitch divided by 2. So D sub M is always going to be the diameter, the major diameter, minus P over 2. So the major diameter here is going to be what we're given in the question, which is 32 millimeters, but I want to convert this to meters because I notice here we're given Newton meter, so we have to be careful here. So it should be 0.032 meters. So on that note, let's just convert this real quick. So 4 is just gonna be the 0.004 meters. Let's convert this as well. This is the 0.025 meters. And I believe that's it. Everything's good. Meter, 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 meter. It looks good. So now we can plug this in. So D sub m, D is going to be the 0.032 meter minus the pitch. The pitch is going to be 0.004 meter, as highlighted above, divided by 2. So we can solve for D sub m, and for that you should get around 0.03 meter. So we have our D sub m, and this is the mean thread diameter. We have a D sub c, so we have this as well. Let's just rewrite this. D sub c is what? The mean collar diameter. These are defined in the handbook, right? And the mean collar diameter that was a given, it's 0.025. 0.25. And what else do we need? We have this. What's L? So the lead here, we know the lead always, if we have a single thread, the lead is equal to the pitch. The lead is going to be the pitch times the number of threads. So let's just write that. It's the pitch times number of threads. And here the lead for a single thread, it's just 1, right? So the lead is the pitch, which is what we're given. The pitch in this case is, in the section cut, it's 4 millimeters, but we converted it. You have to convert it. It's 0.004 meters. 0.004 times the number of threads, which is just 1, right? That's why the lead equals to the pitch for a single thread. If it was a double thread, you would have to multiply it by 2, right? For a double thread, it's twice the pitch. So it would be twice. And a triple thread is 3 times the pitch. You multiply it by 3 for the threads. So here the lead is going to be just the pitch, 0.04 meters. So we have the L value. What else do we need now? I think, so we have the L, we have D sub C, we have D sub M, and all we have to do here is plug those in and solve for F. And we know the torque, right? The torque is given to us. It's 26. So let's do that down here. So T sub R equals, actually T sub R is given, so let's write that as 26. And this equals to my force. This is what I want to find, right? That's the original goal here. And we multiply by what? The force times D sub m divided by 2. D sub m, we determined, is 0.03. 0.03 meters divided by 2. We found that here, right? This, D sub m, is D minus the pitch over 2, as shown by the section cut. And then we multiply by L plus pi. So we multiply this by the lead. And the lead here is 0.004 meters plus the pi times 0.08, which is the friction. So this is the coefficient friction mu for the thread. It's the same for the collar, so that's not going to change. So 0.08 for this. D sub m, we plug it back in again. D sub m is going to be 0.03 meters. Then we take all of this and we divide by pi times D sub m, which is 0.03 meters, minus 0.08, which is the mu value, the friction, coefficient friction, times, so at the end we have to consider L, which is the lead, so 0.004 meters. Close this out, close the parentheses. Then what we do here is we have to add this other portion, right? So this one's easier. You just add plus F, and we multiply by the mu value, which is 0.08 for the collar, is the same. D sub c divided by 2, and D sub c is this value, right? The mean diameter for the collar. So this is 0.08 times D sub c, which is 0.025 meters, and we take all of that and divide by 2. So now we have a bunch of numbers, and what I did first was reduce this and multiply by this. So you can't really do this in the TI-36, it's just too much when you do the number solve function, but you can still do it by hand. What you can do is reduce the parentheses. When you reduce the parentheses, you multiply by this, and we get F times something on one side, right? So let's bring down the 26 Newton meter equals, and when I did this side, you should get around 0.00184 times F. And what I did here was reduce all of this, right? Just this portion here. Then you can add whatever you get for this. You just take that times that divided by 2. So then we have plus the value for that. I got 0.001 times F. So at the end you just solve for F, and if you solve for F here, you should get around, so it's a high number. We're looking at newtons, right? Because this is in newtons. Everything here was in meters. So the force here is going to be 9145.66 newtons. So you just divide by 1,000 to get kilonewtons. I got around 9.15 kilonewtons. So that's that. So this should be our answer. And if we pick our choice, it should be D. That's all. Hope that helps. Please subscribe and like. Take care.